morning, students. Now, as we discussed last time, and we have already completed the complex integration part, the next part I would like to cover, that is line integral. So let us look what we mean by line integral. A line integral of a vector point function fr over a curve C, where r is the position vector of any point on C, is denoted by this. Already before this, I would like to make an appeal that you have to go through the vector calculus, and I assume that the basic of vector calculus already you have gone through and you are knowing very well. So you know what is the vector point function in your vector calculus, and what is the scalar point function. So here a line integral of a vector point function fr over a curve C, where r is the position vector of any point on C, is denoted by this. Under the closed curve C, f dot dr. You know this, what is f? F is here f1 iota plus f2 j plus f3 k. And what is r? R is position vector, means xi plus yj plus zk. Then of course from here you have what is dr? Dr is dxi plus dyj plus dzk. And then again you look this integral under the closed curve C, f dr is defined as, if you assume f is this, r is this, dr is this, then very easily you can define this line integral as f dot dr is equal to this f1 dx, because you know I dot I is 1, j dot j is 1, and k dot k is 1, then f1 dx plus f2 dy plus f3 dz. Here f1, f2, f3 all are the function of x, y and z. So now if you look here, what is x, y, z? The x, y, z always depend on, you know, every curve you can represent as a parametric coordinate also. So here x, y, z depend upon u. Let us suppose u is a parametric coordinate defined within the range a to b and a closed interval a to b. Since ru is the equation of the curve, then f dr may be written as this also. So this line integral may be defined as such also, if between a and b, the a and b, between a and b, their endpoint upper and lower sums are a and b, then f1 dx by du plus f2 dy by du plus f3 dz by du, you can find out this integral, line integral, by using this formula. Now there are certain points always to remember during the evaluation of line integral. The first point is the path of integration C is a closed curve, where then we write, if the path of integration is a closed curve, then we always write this symbol. It means this is replaced by this. This symbol may be replaced by this. Now if dr by du is a tangential vector to the curve C, then line integral f dr is also called the tangential line integral. If that is tangential, then this is also called tangential line integral of f over the curve C. And line integral in this case, in this particular case, is scalar. But there are two more forms of line integral of other type, you can say, that is, this is also a line integral, f cross dr, you know better, and this phi dr. But you know, if here in this case the line integral is scalar, but here the line integral is, what is the difference? Here the line integral is vector. Okay, so this is all about the line integral. Now we can look the problem. One simple problem. If f is this, you look, if 4xy iota minus y square j, then evaluate under the closed curve f dr. Okay, f dr, where C is the area of y is equal to 4x square from 0, 0 to 1, 2. That is given. So how you will go ahead? Just to look, it is given that the function, f is given as 4xy I minus y square j. Then what is its position vector? So there is no vector of k. K is absent. Then the position vector you can write xi plus yj. Now dr, of course, dxi plus dyj, and f dot dr. F dot dr you can evaluate here. So this is, after evaluation you will get 4xy dx minus y square dy. Now just to look what is the curve. The curve is of course a parabola. Just to look, this is the curve. This is a parabola. Y is equal to 4x square. Then dy will be 8x dx. And the points you look, this is the point 1, 2. And this is the parabola x square is equal to y by 4. So here you can sketch the point on the parabola. So it means the vertex is here 0, 0. So you have to evaluate between 0 and 1. So it means 0 to 1 f dr is equal to 0 to 1 4x, and just you put the value, replace the value of y. Just to look here again, the 4xy. What is y? Y is 4x square. So 4x into 4x square dx minus, again you look, y square. So y square means here 4x square whole square, and this dy is what? 8x dx. So now on simplification you will able to write this equation, and after evaluation you will get minus 52 by 3. So this was a type of the problem of line integral. Second, if you look the example, that is, if f is this, that is already given, then evaluate this. The question is to evaluate, little bit change. If here C is the straight line joining these points 0, 0, 0 and 1, 1, 1, that is the point, then how you will evaluate? Just to look, f is already given, it is already given, r is already, you can write xi plus yj plus zk. Why? Just to mind it, because the points are 3 there. Okay. So now dr is this, then f dr, f, just to look, f dr. So this is already here, I, j, k, all the components are here. Then you can rewrite here. And after multiplication again, I dot I is 1, j dot j is 1, and k dot k is 1. You will get this equation. It means this equation of line joining these 2 points 0, 0, 0 and 1, 1, 1 is how you can write. Then you can write here, you know, this is x1, this is y1, and this is z1. Similarly here x2, y2, z2. In this case it is easy, but if that is number, then also you can write. Then you look the formula you know better, x minus x1 divided by x2 minus x1. The x minus x1 divided by x2 minus x1 is equal to y minus y1 divided by y2 minus y1 is equal to z minus z1 divided by z2 minus z1. Then now all the values are here. Then you will get x is equal to y is equal to z is equal to u. Say, let us suppose these are the proportionate value and the value is u. Then dx is equal to dy is equal to dz is equal to du. Now you replace at 0, 0, 0, u is 0, and at 1, 1, 1, u is 1, because everywhere you look the equality, x is equal to y is equal to z is equal to u. It means the integral, line integral will be 0 to 1, 3u square. Just to change, everywhere you can change. You replace this as u, you replace this as u, you replace here as u. So everywhere you can replace in the form of u. Then after replacing, you will get this value. And after integration, you will get 13 by 3. So in this way, this was a different type of the problem to evaluate the line integral. Now, after line integral, there is associated problem if we have to calculate the work done by a force. So let us look what is the work done by a force. If Fxyz is a force acting on a particle which is moved along, let us suppose this is the particle A and B. The particle is moving along the arc and actual length is AB, and the particle is moving from A to B or B to A. Okay. So then which is moved along arc AB, here we assume arc AB, then A to B F dr is equal to total work done by vector F in displacement displacing the particle from A to B. Any force is required to displace the particle from A to B. So what is the force required? That is A to B F dr. That is the total work done. For total work done, to calculate the total work done, we will use this formula. Now, one related thing which is always used in physics much and in mathematics also in some part, what is the conservative force field? So let us look what mathematics say about the conservative force field. So conservative force field, let us define a line integral C F dr under the closed curve C F dr is independent. This is independent of path in the domain D if and only if vector F is equal to del phi. This del you know, that is the vector point function, and in vector calculus you know you are familiar with this del. Del phi for some scalar function phi defined in the domain D, such a force field is called a conservative field. How? It means the total work done by force F from A to B is denoted by this, and this may be written like this here. In this case, del phi dot dr. And as I said, you are familiar with this del. So what is the full expression of this del? Just you look, del over, that is the operator, del over del x, del over del y, del over del z. So del phi over del x dx plus del phi over del y dy plus del phi over del z dz. So now this whole thing you can write like this. This is d phi and this is d phi under integration phi of a to b, and you can write phi b minus phi a. This indicates that it is depend on phi. This depend on phi at a and b at both the points, but not on the path. This depend upon both the points. Here it is depend, it is here depend both the points, but not on every point on the path. Okay. Now there are certain notes. First is if phi is scalar potential. Second note, if F is conservative, then you know the vector F is equal to del phi, and this can be written as del cross F is equal to del cross phi, and this is 0, vector 0, null vector. Now if C is simple closed curve and F is conservative, then you can write this integral will be 0. So this is about the conservative force field. Now, one problem I would like to state here, if F is here, this, you look, if F is given like this, 4xy minus 3x square z square I plus 2x square j minus twice x cube z k, then check whether this integral, this line integral, is independent of C or not. Then for this purpose, how you will go, you know, first of all you have to write what is the given force, given F. The given F is already, you have to write here, already it is given, this is this, and then del cross F. The del cross F, the easiest way to calculate is like this, Ij, that is cross product, the Ijk, del over del x, del over del y, del over del z. Here you can write all these parts. This is from here, and then this 2x square y, this is 2x square, you know, this is 2x square j, not y, 2x square. And now this part is from here. So you have to write all these parts and now expand this. Means how to expand, just you look. I and del over del y of minus 2xuz minus the del you are writing for I, then minus del over del z of 2x square. Similarly, you can write del over del x and del over del z here, and plus k del over del x and del over del y here. Then on calculation you will get here this is 0 by 0 on partial derivative. By taking partial derivative, here you will get minus 6x square z plus 6x square z. Here you will get 4x minus 4x, and in result you will get iota. Iota times 0 plus minus j times 0 and plus k times 0, and in result you will get the vector 0. So it means what? It says that vector F is conservative. Hence, we can prove that this integral is independent of the curve C. Okay? So this already states that with the help of this calculation you have already established if this is 0, it means this is independent of the curve C. Now for practice, please go ahead, these two problems. The first is so that vector f is 2xy plus z cube I plus x square j plus 3x z square k is conservative field. Find the scalar potential and work done in moving on object in this field from 1 minus to 1 to 314. Second problem is little bit different, that is FDR, where F is already, as I have discussed in the through presentation, along the straight line joining the points. Okay, so these two problems you have to do at least 5 more problems from the book of your choice. You can do the practice on line integral. Thank you very much. Thank you. Stay safe. Thank you.